All right, welcome back to Sports Statistics. We're going to be moving on to sort of a new topic. So we're going to step away from p-values, and we're really not going to come back to them unless you decide to use them for like the end of the course, like project that we're going to do. Um, and again, the end of the course project is going to be kind of similar to what you did in third quarter. It's just instead of doing a regression, you'll either do a p-value, you'll do a z-score, you'll do an expected value, all things that we're going to cover in this second half here. So with that, today's topic is the z-score. Now, if you've read the article, Different Look at Best Running Backs Ever, you've got probably a small sense of what a z-score is, but we're going to run through an example together here, and then you'll get to mess around with them more during your lab. So the great thing about z-scores for sports is that it allows us to compare players from different eras. That's one of the all-time great sports arguments. Who's better, Jordan or LeBron? Who's better, Babe Ruth or Barry Bonds? And a thousand other, where you're comparing somebody from the past to somebody from the present. Now, it's not that z-scores give you your final answer on this, but it gives us a tool to sort of analyze that. All right. Now, very simply, a z-score is the observation, so the player's stats, minus the average value of that stat from the era that they played, divided by the standard deviation from the era that they played. So the big idea here is that instead of just looking at raw values and saying, well, this player had, 32 home runs and this player had 37 home runs, we're looking at those totals in the context of what everybody else did in that time period. So, for example, if you hit a lot of home runs during the steroid era, that's less impressive than if you hit a lot of home runs during the what's called the dead ball era. So it tries to put numbers in context by looking at what everybody else did. Now, the reason standard deviation gets involved is because it's not enough just to see how far someone is below or above the average. You have to take a look at also how spread out the data is. So here's a quick little example that I like to go through. Pretend these are quiz grades. So in one class, everybody got an 80. So there were 6 people that took the quiz. Everyone got an 80. In another class, 3 people got 60s, 3 people got 100s. Now, if we look at these, all right, both of these, have an average of 80. So in theory, they have the same average, but clearly there's differences between the two groups. Now, let's say you scored a 100 on the quiz. Is your 100 more impressive when it's part of this class where everybody else got an 80? Or is your 100 more impressive in this class where there were 300s and 360s? I think most people would say it's more impressive over here because you're the only one that got 100. Over here, 3 other people got 100. I mean, don't get me wrong, 100 is still good, but 3 other people did it, so it's not quite as impressive. Now, again, both classes have the same average, so in both cases, you're 20 points above the average, but it would be more impressive here where the numbers aren't as spread out it would be less impressive here where the numbers are more spread out. So that's why we take a look at standard deviation. That's why standard deviation is part of the z-score, because it lets us know how spread out the data is. And if the data is really spread out, then being above the mean might not be as impressive. If the data is really condensed, then being above the mean could be really impressive. All right, so what we're going to do now is just walk through a couple of examples so you can see how this all plays out. So here we have 4 players from baseball. All right, you probably recognize most of those names. All right, we've got Babe Ruth, Roger Maris, Mark McGwire, Barry Bonds. At one point, all 4 of them owned the single season home run record. So Babe Ruth started it at 60, Roger Maris beat him with 61, McGwire beat him with 70, Barry Bonds beat him with 73. Now, one way of looking at this is just saying, hey, Barry Bonds had the most, so that's the most impressive. But another way we can do it is we can look at the z-scores associated with their total. How impressive was their total compared to what everybody else was doing during that time period. All right. The other reason that's important is the baseball season has changed lengths. Maris, McGwire, and Bonds had 162 games. I want to say Babe Ruth had 154 that season. I'm not 100% positive. I know it wasn't 162. I think the number was 154, but it might even be lower than that. So again, it's not fair to directly compare these, but when we take it and turn it into a z-score, all of that concern sort of goes away because we're comparing it with everybody else in their group. All right. So if we want to calculate a z-score for this, all right, pretty easy. We're going to go equals. Now, because there's 2 things on top of our fraction, we're going to start with a parenthesis. We're going to go the observation, which is their individual data. All right, so that's the 60, minus the mean. So that's over here. I'm going to close the parentheses, and that subtraction is divided by the standard deviation. All right, so we can see that Babe Ruth had a z-score of 5.4, which basically means he was almost 5.5 standard deviations above the mean, which is a lot. And now if we drag this down, we can see it for the other players. Okay. So Roger Maris was 3.1 standard deviations above the mean. Mark McGwire was 3.8 standard deviations above the mean. I'm not rounding here. I'm just using the first decimal. And then Barry Bonds was 3.9 standard deviations above the mean. So if we were actually ranking these as far as like which total was the most exceptional compared to the eras, right, we would say Babe Ruth was the first. So he was the most impressive. Barry Bonds was the second. Mark McGwire was the third. And Roger Maris was the fourth. Right? So it's just a different way of sort of looking at stats and allowing you to sort of put them in context instead of just looking at the raw numbers. We sort of compare that raw number to what everybody else did during that time period. All right, so that's one way we can use it. We can use it to compare things across time. All right, the other way we can use it is to sort of compare across stats. All right, so here we have an MVP season from Michael Jordan. Here we have an MVP season from LeBron James. All right, 2 of the, best basketball players of all time. A lot of people debate, who's better, Jordan or LeBron. This is another arena where we can take advantage of z-scores and use z-scores. And what we can do is we can kind of take all of these different stats, field goal, 3-point, 2-point, free throw, offensive rebound, defensive rebound, assists, steals, blocks, turnovers, points, and turn them into a single score. All right, because the thing about a z-score is it doesn't actually have a unit. All right, it's just how many standard deviations above or below the mean something is. So if we convert every single one of these stats into a z-score, all right, we can get a combined sort of total for Michael Jordan, and we can get a combined total for LeBron James, and it lets us sort of count each stat as part of a bigger picture. So yes, Michael Jordan had more points than LeBron James, but LeBron James had more blocks than Michael Jordan. All right, so it's going to allow us to kind of look at a more complete picture and sort of condense the player down to a single number that we can compare. All right, so the first thing we're going to need to do is calculate the different averages for our players. All right, so over here on 95 and 96, we have some of that data right here. So what I'm going to do is I'm going to go here to Michael Jordan. I'm going to go equals average. I'm going to go to 95, 96. And I'm going to highlight all of these field goal percentages. All right. So I've highlighted all those. I'm going to hit enter. And that's going to give me the average field goal percentage from that season. All right, there it is. There's a big long decimal. If I drag it across, everything's in the same order. So it's just going to work. And like the next one is the 3-point percentage. The next one is the 2-point percentage, and so on and so forth. So it will work and kind of give me everything I need. Like if I go over here, we can see that everything's in the same order: field goal, 3-point, 2-point, free throw, and so on and so forth. So I only have to do it once, and then I can drag it over and get sort of all the values that I need there. All right, so I'm going to do the same thing for LeBron James's season. All right, so we're going to go average, left parenthesis. I'll go here. I'm going to highlight all of the field goal percentages from that season. All right. And then I get the average free throw percentage from that season. I'll drag it across. So now I have the averages for the 95-96 season. I have the averages for the 2009-2010 season, all right, because we need the averages if we're going to do a z-score. All right, I'm going to do the same thing for standard deviation, and I'm just going to use STDEV. All right, now we're not using the whole NBA. It's only a sample of the players. So when you do STDEV, that'll give you the sample standard deviation, which is what we want in this one. So you don't have to worry about population or sample for this one. Just STDEV, that will give you the right calculation. And then we're going to go and just do the same thing. All right, I'm going to highlight field goal percentage again, only this time instead of average, we're doing standard deviation. So highlight all that, hit enter, drag it across. Now I have all my standard deviations. All right, and then I'm going to do the same thing for LeBron James here. Equals STDV. Go over here, highlight all of the field goal percentages again. All right, there they are. Drag it across. And now we can actually calculate our z-scores here. So what we're going to do, we'll go equals, and then left parenthesis, the player's stat, that's our observation, minus the mean, close the parentheses, divide by the standard deviation. Okay. That's going to give us our z-scores, and then I'm going to drag it across, And I'm going to stop right here at turnovers, right? Because turnovers is one of those stats where being higher is bad. Like you don't want to have turnovers. Turnovers are not a good thing. So here we can see Michael Jordan had 197 turnovers. The average was 130. So we don't want to give him a positive Z score here because having more turnovers than average is a bad thing. Now, part of that is just because Jordan handled the ball more, so he had more opportunities for turnovers. But again, we're not going to worry about that right now. So the way we kind of account for this being bad is when we put in the formula, we start with a negative sign, and then we do the same exact thing we always did. All right, so observation minus the average divided by the standard deviation. And that'll just make it so that if it was negative, it becomes positive, and if it was positive, it becomes negative. So we can see here his z-score is negative, which is what we want, because being above the average in turnovers is actually a bad thing. All right, and then let's just do this one, points. Again, that's a regular one where being above is good. All right, and we can see a clearer picture of Michael Jordan. His field goal percentage was above the average, about half a standard deviation. He was almost a full standard deviation better than his peers in 3-point percentage, about half a standard deviation better in 2-point percentage, one standard deviation in free throw percentage, half a standard deviation in offensive rebounds, a full standard deviation in defensive rebounds, a full standard deviation in assists, 3 standard deviations above in steals. He was about even in blocks. He was pretty close to the average. He did have way more turnovers, but again, it's probably because he had the ball more. And his scoring was well above, almost 4 standard deviations above the average. All right. So what we can do is we can take all of these z-scores and add them together. So equals sum, left parenthesis, and get a total and say that across all of those stats, Michael Jordan was 11 standard deviations above the average, which is really, really good, but that's what you'd expect with an MVP caliber season. So let's now do the same thing for LeBron and see who comes out on top. All right, so equals again, observed minus average divided by the standard deviation. We'll drag it across. Again, I'm going to stop here at turnovers because that one is the negative one. So I'm going to do negative and then just type my formula in again. It's a short formula, so it's easy enough to do. And then put this one in here as well. So, all right, so here's LeBron's scores. All right, we can see he was 1.5 above in 2-point percentage, 1.5 above defensive rebounds, 3 above in assists, 2 above in steals, 1 above in blocks. Again, more turnovers, but part of that's just because he's playing more minutes and handling the ball more. Above in points, not quite as high as Michael, but again, above. So we can take all of these together. We can sum them up. All right. And we can see that they're close. All right. But Jordan's season would come out slightly above LeBron's season. So 11.24 standard deviations to 10.99 standard deviations. So if we're just comparing these two seasons, you would probably say Michael Jordan's season was a little more impressive than LeBron James's season. Super close, but maybe slightly more impressive. And you could also imagine doing this for not just one season, but you could do this for their entire career. We could go season by season and get a score for every season of Jordan's career, every season for LeBron's career, and see who has the larger total overall and do a really in-depth analysis of who has the better career. and it would just give you this another picture on, which player was truly better. Now, when I say truly better, remember we chose the stats. All right. So field goal percentage, 3-point percentage, 2-point percentage, free throw percentage. If we had chosen different stats, we might come up with a different answer. So it's not like z-score analysis is, oh, once you have a z-score, it's done. There's no more argument. There's still argument over what stats you should include. All right. Did I choose the right stats to compare players? Or should I have chosen different stats? I mean, you could make the argument, why did you include field goal percentage if you also included 3-point and 2-point? Aren't those basically the same thing? And yeah, you would have an argument there. So it's not that this settles arguments, but it's another tool that you can use when analyzing things. And it's kind of interesting because it lets you condense sort of everything into a single number. If you're familiar with baseball stats, there's something called WAR, wins above replacement. It's the same general idea. You're trying to condense everything down to a single number. That's what this z-score analysis does. It allows us to condense everything down to a single number. So your lab for this activity looks like this. It focuses on the most recent baseball season. So the formula is up at the top of the lab. This chart is for you to collect all the means and standard deviations that you're going to need. So in the spreadsheet, there's going to be a tab for 2019 hitters, 2019 pitchers, and 2019 closers. So pitchers and closers got separated out into different categories. So you're just going to calculate mean, again, using equals average. You'll calculate standard deviation equals STD EV. Again, just do it once and then drag it across. Do it once and then drag it across. So you'll fill in this chart, and then this is going to just ask a couple of questions about generating z-scores and comparing players. So here's 3 MVP candidates. Calculate their z-scores, see who was the highest. Here are the 2 Cy Young winners. Calculate their z-score, see who's higher. Compare 2 closers. This just asks you to speculate on what other stats should we probably include. I just went with some of the most basic stats, but like, what's a stat that might be better to use? And then 5 is just picking 2 players of your choice, presumably 2 players you like, and calculate who has the higher combined z-score. All right, so again, it's just going to be doing kind of what I just walked you through. You'll calculate some means, you'll calculate some standard deviations, and then you'll use their individual stats to actually calculate the z-scores and see who comes out on top. All right, so that is it. I hope this was helpful, and best of luck.